is lesson 6-4, standard form. Standard form of a linear equation is an equation in the form of ax plus by equals c, where a, b, and c are all real numbers, and a and b cannot both be 0 at the same time. An example of this would be like 3x plus 2y equals 12. That would be an equation in standard form. The x-intercept is similar to the y-intercept. The y-intercept is the y value of where a graph crosses the y-axis. The x-intercept is the x-coordinate of the point where the line crosses the x-axis. Both the intercepts can be used to graph an equation. They're very helpful in this matter. Slope-intercept form of equation is just one form of a linear equation. We've been working with slope-intercept form for the last couple of lessons. Now we're going to look into standard form. Standard form is often very helpful for making graphs, especially if the number that's after the equal sign is divisible by both the number in front of the x and the number in front of the y. To graph a linear equation in standard form, we use the intercepts. Very simple to do. To find your intercepts, to find your x-intercept, let y equal 0 and solve for x. And to find the y-intercept, let x equal 0 and solve for y. And I have a nice little shortcut I do for that makes it really easy, so you don't even have to try to remember that. It's just a little shortcut that I'll show you that will help you be able to graph using intercepts. All right, first thing we're going to do is we're going to find the x and y intercepts for each of these equations. Because if you can find the intercepts, you can graph. It's very, very simple. So let's look at this first equation, which is not written right. I should say 3x plus y equals 12. Let's change that really quickly. 3x plus y equals 12. If 3x plus y equals 12, I'm going to solve this equation for x and for y so that I can find the intercepts. And the easiest way to do this is I make a little x and y table, and I put two zeros in there. I let x equal 0 and I let y equal 0. If x equals 0, the 3x literally goes away. You have 0 plus y equals 12. So you have 3 times 0 plus y equals 12. So essentially, this 3x here part goes away. So what does y equal? Y equals 12. And if y equals 0, I have 3x plus 0 equals 12. So I basically divide by 3. X equals 4. So here, x equals 4. So now to find my intercepts, it's very simple. You're just going to read down your table. My x-intercept is 4. My y-intercept is 12. And I'm going to write that off to the side. The x-intercept equals 4. And my y-intercept is equal to 12. You read your table down when you're looking for the intercepts. For the second one here, negative 4x minus 3y equals 9. This one's not going to be quite as pretty as number 1 here, but it's done the same way. Again, I'll make a little table of values. I'll put in 0 for x and 0 for y. So if x equals 0, literally the x goes away, and the negative 4x minus 3y equals 9. This 4x goes away if x equals 0, and I have negative 3y equals 9. So I'll divide by negative 3, and y equals negative 3. Okay, for the second part of that, I'll pull this down so you have a little bit more space to see. If y equals 0, I have negative 4x minus 3y equals 9. If y equals 0, this goes away, because 0 times anything is still 0, so it goes away. So if I divide by negative 4, x equals 9/4, which you could rewrite as negative 9/4 without my negative sign. You could rewrite as a mixed number, which would be negative 2 1/4. So my x-intercept then equals negative 9/4. My y-intercept equals negative 3. next equation here. Negative 3x plus 2y equals 6. My little x and y table over here. X is 0 with y is 0. If x is 0, this goes away. And I have 2y equals negative 6. Negative 6 divided by 2 is negative 3. Y is negative 3. If y is 0, this goes away. And I now have negative 3x equals negative 6. Negative 6 divided by negative 3 is positive 2. So my x-intercept is 2. My y-intercept is negative 3. As simple as that. The intercepts are actually very, very easy to find. Especially if you just want to make the little table, then all you have to do is read down the table. X-intercept is 2. Y-intercept is 2, negative 3. Okay, you read down the table to figure out your intercepts. Okay? All right. That's finding the intercepts. Once you've solved an equation for the x and y intercept, it's rather easy to graph it. You make sure you know the intercepts, as long as the intercepts land on a coordinate point and not on a weird fraction like 5 and 3/12, or 5 and 9/17, that would be really obnoxious. Simply plot the intercepts and draw a line between them, and then make sure you label your graph. So we're going to graph these two equations using intercepts. If I wanted to graph 5x plus 2y equals negative 10. Okay, I'm going to make my little x and y table. 0 and 0. If x equals 0, I have 2y equals negative 10, so y equals negative 5. If y equals 0, I have 5x equals negative 10. Negative 10 divided by 5 is negative 2. So my two intercepts, if you want to, you can read the point. This point is 0, negative 5, or it crosses, okay, you can either read this, the x-intercept is negative 2, it crosses, label your axes, x and y. It crosses my x-axis at negative 2. Here's negative 2 on the x-axis. It crosses my y-axis at negative 5. 1, 2, 3, 4, here's negative 5 on the y-axis. And I just simply draw a line. Use a ruler, I can't do that on the smart board, we talked about that. And label the equation. 5x plus 2y equals negative 10. Simply plot 2 points, draw your line, because any 2 points make a straight line. Hopefully they're the right 2 points. Okay, so you could either plot the x-intercept as negative 2 and y-intercept as negative 5, or you could read the points. 0, negative 5 is one coordinate point. Negative 2, 0 is the other coordinate point. There's negative 2, 0. There's 0, negative 5. Same thing. If we look at problem number 2 here, I'm going to label my x and y axis really quickly. I'm going to make my little table. If x is 0, I have negative y equals 6, so y equals negative 6. If y equals 0, I have 2x equals 6, so x divided by 2 is 3, or 6 divided by 2 is 3. So there's my 2 points, my x-intercept and my y-intercept. My x-intercept is at 3. X-intercept is 3, y-intercept is negative 6. So I cross the x-axis at positive 3, which is right here. I cross the y-intercept axis at negative 6. 1, 2, 3, 4, 5, 6, which is right there. Draw my line. Oops, I missed a little straighter line, but I missed my point. And label your equation. 2x minus y equals 6. Simply done. Not a hard concept to be able to do. Okay, the standard form for an equation ax plus by equals c. Either a or b, but not both, may be zeros. If a or b is 0, the line is either a horizontal line or it's a vertical line. So let's look at the following. Because you have to know when it's horizontal and when it's vertical. So I'm asked to graph y equals 5. Okay. In standard form, we have 0x plus y equals 5. Okay, so if x equals 0, y is 5. If y equals 0, you're looking at it going, I don't get it. So essentially, you're looking at it this. No matter what x is, y is 5. So if I made a little x and y table, no matter what I put in here for x, y is 5. So if I put in negative 1, y is 5. If I put in positive 12, y is 5. If I put in negative 4,072, y is still 5. No matter what x is, y is 5. Therefore, where is y 5? 1, 2, 3, 4, 5, right here. This would be a horizontal line. Okay? This is the equation of y equals 5. If you ever get a problem in the form of y equals something, okay, we'll say y equals a constant, since we used k for a constant last time, that will always be a horizontal line. Okay. If we look at the equation, oops, I forgot to label my x and y axis. Really critical that you label your x and y axis so we know which one is the axis and which one is the line of your graph. And so now you understand why I keep saying that. If we go to graph this second one here, x equals -4, it is saying no matter what y is, x is -4. So if I have a little x and y table here, no matter what y is, x is going to be -4. Y can be 0, y can be -2, y can be +8. No matter what y is, x is -4. So if I was going to graph that, x is -4, 1, 2, 3, 4. Here's x is -4. Okay, no matter what value y is, x is -4. So here if y is 3, x is -4. If y is -2, x is -4. So this would be a vertical line. X equals -4. It's apps. It's opposite what you think it should be because you think, oh, x-axis goes horizontal. So if anything's x equals, it should be a horizontal line, but it's not. It's a vertical line. Okay, so if you get x equals a constant, that will be a vertical line. The last thing we're going to do is learn how to convert from standard form, convert from slope-intercept form to standard form. We already know how to convert from standard form to slope-intercept form. We solved it for y. We've been doing that. We did that back in chapter 5, and we're doing it again in chapter 6, but sometimes we have a difficult time translating this to standard form. The most important thing you need to understand is when translating to standard form, you must clear all decimals and fractions and write the equation using integers, positive or negative, whole numbers. All equations must be written like that. So if we're going to take this first equation, y equals 2/3 x plus 6, and we're going to write it in standard form, the first thing we need to know is standard form, if you remember, is ax plus by equals c. It has to be something times x plus something times y equals something that doesn't have an x or a y. So the first thing I need to do is get all the variables on the left-hand side and all the numbers without variables on the right-hand side. This 2/3 is on the right-hand side. It needs to move to the other side. To do that, I will subtract it on both sides. This side it cancels. So I am -2/3 x plus y equals 6. Because x comes before y, we write it in xy form. This would be great, except for the rule that says you must clear all decimals or fractions. You cannot have any decimals and you cannot have any fractions in order to be in standard form. So we need to get rid of the 3, not the 2, but the 3 associated with this problem. So in order to clear the fraction, I'm going to multiply by the common denominator, which in this case is 3 because it's the only fraction I have. So I'm going to take this entire equation and I'm going to multiply every part of it by 3. And I would suggest doing it this way versus taking the whole problem and putting it in parentheses and multiplying it by 3, because then you won't miss something. Okay, this 3 cancels with this 3, leaving me with -2x. 3 times y is 3y. 6 times 3 is 18. So you can have -2x plus 3y equals 18. Or if you prefer not to have the first term being negative, you can have positive 2x minus 3y equals -18. If either one works, they're both perfectly appropriate, and I do not have a preference of which one to use. But it must be written with integers. Let's look at number 2 here. If I needed to get this in standard form, I need to take the -2/5 x and move it to this side of the equation. So I'm going to add 2/5 x because I have to do the opposite of what they did to it. So I have 2/5 x plus y equals 1. Again, I have a fraction. I can't have a fraction, so I need to multiply by the common denominator. Since there is only one fraction, the common denominator is that fraction's denominator, which would be 5. I'll multiply everything by 5. These two 5's cancel out, giving me 2x, plus 5 times y is 5y, equals 5 times 1 is 5. And there I have my equation in standard form. Let's look at one more. Y equals 5 halves x minus 3. Again, I must get the 5 halves to the other side. So I will subtract 5 halves x. Whatever you do one side of the equation, you must do the other side of the equation. So these will cancel. And I will have negative 5 halves x plus y equals negative 3. Be very careful not to lose negative signs. Multiply by the common denominator, which in this case is 2. These will cancel, leaving me negative 5x plus 2y equals negative 6. And there you have your equation in standard form using integers.